This is Darrell presenting Apple's Develop in Swift Fundamentals curriculum, Unit 2, Lesson 2, Functions. Because most programs don't just run linear code, we need functions. Here are two examples where we call functions. In the first, tie my shoes, we have no parameters. In the second, make breakfast, we have two parameters. The first parameter is named food and is of type string, and the second parameter is named drink, and it is also a string. Typically for functions, we use lower camel case. So we start a function or method name with lowercase, and then we capitalize each later word. That's different from types, where we use upper camel case, where we capitalize every word, including the first one. Here's the syntax for defining a function. We start with the func keyword, and then we have the function name. Then we have the list of parameters in parentheses, and we specify a return type after a dash and a greater than sign, which is like an arrow. And then we have the body of the function inside braces. Here's an example of a simple function where we display pi. We have no parameters and we have no return type because we're not actually returning a value. Instead, we are just printing to standard output. And then here's an example of us calling display pi. We do, even though we have no parameters, we still include the parentheses the empty parentheses when we call the function, which helps tell the compiler that we are calling a function. And then pi gets displayed to standard output. Here's an example of a function with a single parameter. The parameter's name is value, and it is of type integer. We have no return type for this function, so this function is not returning anything. And here's an example of us calling the function, where we call triple. We specify both the parameter name and then a colon and then the value, and then it is executed. Here's an example with a function with multiple parameters. We have first number was the name for the first parameter, and it is of type integer, and second number is the name of the second parameter, and it is of type integer. We can reference the values of them using those names inside the implementation of the function. So our result is equal to first number, which is an integer, times second number, which is an integer. Again, we have no return type, so we're not returning anything. Instead, in this case, we're just printing to standard output. Here's an example of us calling the multiply function. We include both parameters, their names, and then a colon, and then the values. And when we call the function, we have to call the parameter names in the same order that we defined it in our function. Properly named arguments help document the function. Functions can return a result, and the result has to be of a specific type. In this case, our new version of the multiply function has two parameters, both of type int, and it returns an int. Then our code, in every possible path of code, we must have a return statement which returns a result, and that result must be of type integer. In this case, we define a new constant result, and that result is the result of multiplying the first number, which is an integer, times the second number, which is an integer. So the compiler can infer that result is of type integer, and so returning result, when we return result, we are returning an integer, which is consistent with the specification of the function where we promised to return an integer. So this is our valid function. Because our return value is an integer, we can use that integer. In this case, here we call the multiply function, and the compiler knows multiply will return an integer, so we can define a new constant myResult, and the compiler can infer that it is of type integer because the function multiply is returning an integer. And then we can use this new myResult integer, constant integer, in string interpolation. We could even go further, and we could actually call our function directly in our string interpolation. So in this case, here is a string literal that we are printing out, and we are using string interpolation. And rather than just putting a variable here, we are putting a function here and calling the function. The function will return the integer 50, and so we will print out 10 times 5 is 50. If a function is a single line, then we may omit the return keyword on the line as long as the line results in the correct type. In this case, first number and second number are both integers. Multiplying them results in an integer, which matches the type of the function. So we can not include the return keyword here, and the function is still valid. This only works for single line functions. Functions commonly use the same label internally and externally for parameters. In this case, this function's parameter name is first name, both internal to the function during implementation and external to the function when calling the function. Sometimes having the same name inside and outside the function can be awkward. In this case, we like these names external to the function. Say hello to Luke and Dave. That reads off very nicely and is very what we call swifty. However, if we use those same labels inside the function, then we would have a parameter name to and a parameter name and it's not clear what that means. We like our labels to be self-documenting both inside and outside the function, and having the ability to have different names inside or outside the function for the same parameter is a good idea. Here is how we can implement a function where we have a different argument label, which is an external name, versus the parameter name, which is the internal name. In this case, the first parameter, we have func say hello to person colon of type string. The first item, to, is the external name, or the argument, also called the argument label, and then the internal name, the parameter name, is person. So internally for the implementation, we use person, but externally we use to. Likewise, for the second parameter, the external name, argument label, is and the internal parameter name is another person. That way, when we're writing our function, we can print hello, person, and another person, and another person. Those labels are self-documenting. Meanwhile, externally, we can call the function say hello to Luke and Dave, so the whole function reads off in a very swifty manner. Sometimes it is nice to completely omit the external label. However, you always need to have an internal name for your parameter. Here's an example of a function we've been using repeatedly, which does not have an external argument label. Print. We can print, and then we just put our string literal. Note there is no label there. We don't say contents colon or anything like that. Here's an example of an add where we define an add function showing how we can omit an external label. We use an underscore for the first label, which is the external label, and then the second label, which is the internal label, is first number. So internally, we're using first number for the implementation. Externally, we don't have a label for that first parameter. And that way, we can have a function where we can call it add 14 to 6, which reads off very swifty. We can have default parameter values. Here's an example of a function display where the first parameter, team name, is required. However, the second parameter, score, we could include score as a parameter, or if we did not do so, then a default value of 0 would be implied, thanks to this equals 0 at the end. Thanks to that, we could call our function in two different ways. We could specify both parameters, including a score, or we could skip the score. When you have a default parameter, it is generally recommended to include the default parameters near the end. That concludes the unit on functions. If you're following along with the Apple curriculum, Apple has a playground on functions. The slide deck is copyrighted by Apple. The slide deck is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike 4.0 International License.